questions for me? Yes, sir.
Just so I understand, would this be considered lecture number 10, or would you go back to number 1?
Say again.
So like for like the YouTube videos,
Sure.
you numbered them all like 1 through 9.
Yep.
So would this be the 10th one, or would you go back to number 1?
This is 11. So I did post one last night that you might not have seen yet. But I will keep numbering them just in a general order, so you won't get confused that way. I don't know how many classes we'll have. How many weeks in the semester? I think it's like 12. So three times that, 36 videos maybe. Yep. Have you all seen the test? You guys have all been able to access the test I got. Some folks who emailed me about some trouble. I know I emailed at least 1 or 2 people a version that maybe they could read a little bit better. But otherwise, yep, that will be due, what did I say, today? Okay, so the end of today, good. Let me know if that's a problem, but nobody seems to be saying it is. Yes, ma'am.
What about the perspective essays? It's like 3 of them.
That's right. Those are all due at the end of the semester. And so you just have to be responsible and make sure you get 3 of those in by the end of the semester. Yeah. There's no due date other than that. Yes, ma'am?
When we turn in those essays, how quickly do you think you'll get them graded? Or does
Not
it
very
just...
quickly.
Okay.
Not very quickly at all. I'm not grading them tough or by any means. I mean, basically, if you met the page count, and I see that you put some semblance of thought into it, then it's kind of a check plus, check minus kind of deal. So, kind of, did you do it or not, really?
Okay.
So I usually wait to do those. I have a TA that signed up to help me out this semester. I had a couple, but they both graduated, and so usually those will be a little bit faster, but maybe when the TA signs on, she'll grade them pretty quickly. When I do it, I'll be honest, I don't grade them to the end of the semester. Yeah.
These tests, they can be about anything that we've covered in the course, right?
Yeah. Yeah. Anything. Okay, so what we started talking about yesterday, I know you weren't here, but that video is up. What we started talking about yesterday was the science of psychology. And so what we're looking at here is the ways in which scientists, psychologists in particular, are able to think about some of the things that we want to know, some of the questions that we have as psychologists about people, human behavior, human interaction, etc. And so yesterday we just started out by talking about what the scientific method is and how maybe that applies in some specific ways to psychologists. So check that out, pay particular attention to these words, operationalize and generalize. They're not exactly related, so I don't think they're like opposite terms or anything. To operationalize, I'm not going to give you a definition, but to operationalize means to take something like love, right? Something that in psychology we might study. Does this group of people love more than this group of people in a relationship? Which one loves the other more, right? If we're interested in studying something that has to do with love, we have to be able to understand what we mean love. We can't just measure this thing like it's a chemical or like it weighs something or like who's taller in a relationship, right? That's something we can easily get a number or quantitative value for. But if we're going to do science to love, we have to operationalize it, which means basically take it and try to break it down into something that we would understand or be able to measure in terms of love. So, you know, we spent class last time doing this, so we might be something like, I don't know how many kisses you give or get in a week. It could be you fill out a survey that says stuff like, I really care for my partner. My partner is the most perfect person in the world, right? You're gonna try not to use the word love because you don't want to give the exact piece, but you want to ask questions that get at that, right? And you might ask something like, I don't know, will you die for your partner? Or something like that, right? And so here we're trying to operationalize that word, because if we just say love, we don't really know what that means. I mean, we know what it means, maybe, but we don't know how to count it. We don't know how to do science to it. And so operationalization or operationalizing is breaking it up into these types of things. So we could do that with joy, we could do that with anger, we could do that with intelligence, we could do that with competence or confidence, right? We could use all of these words that we might be interested in psychology, and then begin to figure out how to break those up into something we can measure, because this is what's important here. The word generalize is something different, but this is after you get your results. And let's say I go to UCM and I want to study the amount of students that, I don't know, it's something here, the amount of students that have ever driven a tractor, okay? So this is a simple study. There's not a lot to generalize, or here's something I can probably just count, right? Raise your hand if you've driven a tractor, raise your hand if you never have, right? This type of thing, and I can just add up, okay, this group versus this group. This many, 76 have driven a tractor and 59 haven't, okay? So let's say I take this study and I want to go out and I say, oh God, I should have done better math. Let's do better math. Really easier math, okay? So let's say I take this study and I say, hey, I found out that it looks like about 75% of Americans have driven a tractor based on my research. Any problems with that? What you got?
You just did the class. You can't assume that all of America is 75%.
Well, why not? I mean, it's a pretty diverse group.
It's not accurate.
Why? What's inaccurate, perhaps?
You need more like numbers. You need more people instead of.
Well, you got to give me a reason to believe that this group of people is not reflective of everyone else. Yes, sir.
We're currently in the Midwest, where a lot of people have been near farms their entire lives.
Very good, right? So here's what I'm looking for, right? This is the Midwest, where there's just more farms. This school in particular is in a pretty rural area, right? I drive past 4 or 5 farms a year every day. So, there's a lot of farms around. If I go up and ask somebody in California or up in Boston, right, I might get, not even reverse this, right? I might get 95%. So the idea of generalizing is really just interested in, to what degree can I apply my specific results? This is the results that I got from my study. To what degree can I apply those results to the broader population? To what degree does that apply to everyone else? Or at least everyone else that I'm interested in. What does that mean? Well, maybe in this study I didn't ask every UCM student, have you driven a tractor? Maybe I only asked women, right? And now my generalization is not about everybody. Who's it about?
Women.
It's about women. So now I would say, I'd be wrong again probably, but I would say it looks like 75% of women have driven tractors in the United States, right? I'm still trying to generalize this number. So again, generalize just means you take your, what we call sample. Those are the people that you are studying. Those are the people that you do the research on. You take your sample and you try to apply it to the broader population, is the word that we use. You try to apply it to the broader population that you're interested in, okay? Sometimes it's everybody or the whole country, and sometimes maybe it's just women or college students or whatever, children. Does this make sense? Okay, so that's what we talked about yesterday. Go watch that video and we'll talk about it a little bit more in depth. I give a few more examples and do some work with the class. Today, today what I want to talk about is the methods that we use to do psychology research. So I've got 5 here. There are others, and what you'll see is that there are ways in which we can combine some of these things. But this is just to get you started. So the first thing we're going to look at is what's called a case study. Anybody heard of a case study? Yeah, what's a case study?
It's where, at least in psychology, where you look at a specific person, whether that was historical or whatever, and maybe a certain condition that they had, and you looked at how it affected them and all that kind of stuff.
Okay, very good. And so what's the key piece of that? What's the unique thing about a case study? You did say it.
It's something like very specific.
Okay, something very specific, yes?
Yes. Like
Anybody
a
else know?
condition.
Yes, sir?
It's, I don't know, it's kind of like a breakdown of what they have, and like in nursing, I know, for example, we take the problems that they have and we analyze them, see how it applies to things.
Okay. Anybody, you guys don't know the specific here though? Yeah, one more
Isn't
time.
like case studies focused on a specific individual, just one person?
That's what I'm looking for, right? The thing, and you are saying it, but I wanted to point it out. The thing about a case study is you're looking at a specific individual, usually. Sometimes you might call a case study if you're looking at a specific situation as well, just something that's going to occur, for instance, once, or something that occurred once, right? We just got past 9/11. There's probably a lot of case studies of 9/11, right? That's not something that happens over and over again. That's not something that we have a lot of data about in terms of it's happened several times, so we can think about what happens if this plane, what happens if this building, right? It's just this one incident, and so if we want to think about what does it mean to have this type of attack on our country and the effect on the people and blah, 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 right? We really can only look at that one incident. We want to look at something like planes flying into buildings, right? That's not something that we have a lot of. So similarly in psychology, what's an example that you can think of in which you might prefer to use a case study? Why would you just look at one person?
Because that one person has the thing that you want to study, right?
Because that one person has the thing you want to study, so why not just get a lot of those people?
Because isn't a case study typically over like a rare thing?
Very good. Case studies tend to be used on something that's relatively rare, right? It's not the best methodology, but it is a methodology where we can really dive into, I don't want to say it's not the best, I'm not going to rank it, but it has some problems and we'll talk about those, but what it's really good at is digging deeply into one specific thing. Anybody Amish? All right, I always use an Amish example. I don't think it's going to be offensive, but maybe there's an Amish person in here. Probably not. So imagine that somebody raised their hand when I said that. Is anybody Amish? And somebody in the back with a big beard and a top hat puts his hand in the air, says, "Yes, I'm Amish." I say, "Oh, wow, this is amazing." Listen, I've been asking that question for about 5 years now. Nobody's ever said that they were Amish. Do you mind hanging back? I'm just going to point to you like you're this Amish guy. Do you mind hanging back after class? And I'd like to ask you a lot of questions about what it's like to be Amish, right? I'm starting a case study. I'm starting a study on, oh, this is so rare. This is so rare. So I really want to dig into this guy's head and figure out what's it mean to be Amish, right? I got all these questions. And so let's say he agrees and we meet, I don't know, for 2 or 3 weeks, once a week, and we meet for an hour and I ask him all these questions about what it's like to be Amish, and he gives me all these answers. And so now I want to take what I've learned from that person, from that guy, and I want to generalize it, right? This is really what science is after, right? Because we want to be able to predict or understand what might happen in the future or next time, right? Sometimes it's historical, but generally, especially in psychology, especially in medicine, we're trying to forecast. We're trying to get ahead of it. And so I want to generalize. I want to say, I did this great case study over 2-3 weeks, several hours of interviews, and I wanna say, I know all there is to know about Amish people. And I start listing off facts and information. What might be some problems with my generalization?
You only talk to one Amish person.
I only talk to one Amish person, right? This is always gonna be the problem of a case study. Is if you're just doing one person or one situation or even just one group, small group of people, right? I don't have a lot of data. And so the more numbers you have, generally, this formula isn't perfect, but the more numbers you have, the better able you are to generalize, right? Because the more different types of people you have in your study. If I just use Midwesterners, this is tough, but if I did 100 people out of each state, I'd probably get a closer sense of how many people have driven tractors. But what else is wrong? Yeah.
It's a male, so maybe a female experience is different.
Okay, so he's got a one-sided experience based on his being male, and in that particular culture, not that it's not important in every culture, but in that particular culture, there's gonna be very strict, we assume, gender roles. And so he's really only gonna have that perspective, probably. He can, he's seen women, he's talked to them, he knows what goes on there for the women, but that's not his experience. Very good. Something else. Something else about this guy in particular.
He's at school,
Yeah, so
that's not normal.
that's not normal. Often, not always, but often when we're doing a case study on something that's super rare, we have to consider, how did we get this one, right? If I have access to this Amish guy, and Amish folks do not generally go to college, right? He's already strange. He's already unlike most of the other Amish folks. This again makes my generalizability difficult, because I'm studying somebody who, just by being here, is different than the group that I'm trying to understand. Now again, it's the only Amish person I've ever met. So, do I just not do the study? Or do I say, listen, this isn't perfect, but I can do a case study and get some information, right? So these are the pluses and the minuses of the case study, right? You can study a small group, you can get really deep information about that group. You can do follow-up questions, right? If that person tells me something and later I go, wait, I didn't understand what they meant about the chair ceremony. Next time we meet, I can say, hey, tell me more about this chair ceremony. It sounds odd. This makes sense? Case study. Questions? I know who's here. Okay. So the next form of study is the observation. This is often called a naturalistic observation, but observation is fine. An observation is what it sounds like. I just go watch. I go watch, and generally with an observation, I'm either going to try to hide myself or at least try not to interfere. This might look like I stay very far away, out of sight, and I maybe use binoculars or maybe I have recording equipment there. This might mean I'm behind a two-way mirror, right? This might mean maybe I'm studying classroom activity. I'd have to get your consent, right, the first day. There'll be a camera in the room pointed at you. I'm gonna see how you respond to my jokes. That one went over well. So I'm gonna, put a camera here and I might just watch that later and sort of look for different response styles, right? So observation is this removed way, very different than the case study. Of course, where you're in there, asking questions, asking follow-up questions. What did you mean by this? The case study, the observation is far away from that. So, what are some pluses and minuses of using this methodology of an observation? What's good about this, especially with regard to this year? And what's maybe troubling about it? Yes, sir.
If you're watching some sort of like species in their natural habitat, you're not getting any human interference from it, so it's very good like raw data.
Very good. You get this sort of raw data because you're not getting as much, at least, interference from the researcher, right? If I had a camera here and I told you on the first day, hopefully by week 3, you forget about it, or at least get used to it, and you start acting like yourself again, right? Or if I'm behind a two-way mirror and you're not sure if I'm there, hopefully you're gonna act a little bit more like yourself. So one of the biggest benefits of the observation is that there's not any researcher involvement, or at least there's less. With the case study, again, there's a lot of involvement. I'm sitting with just you. It's not even a group. I didn't hand out a survey. I'm sitting with you, asking you questions. If I ask you something embarrassing, when was the last time you got drunk? When you were this Amish 18-year-old UCM student, you might not want to tell me that. Oh, I've never been drunk. Okay, right? And so because of that closeness, I might not be able to get that information, but if I'm just following you around, put a microphone in your pocket, I'll just know if you got drunk that week. Any other benefits you can think of an observation? The biggest one is this removed nature of things, right? This sense that you're getting something a little more natural. You're getting something you're not setting up. You're not forcing them to think about something that's not happening right now. You're just seeing it happen. But there's some drawbacks. Let's say nobody ever comes to my class who's Amish, and I'm still really interested in the Amish folks. So I'm gonna go out to some Amish village, town, I don't know. I'm gonna go out to some Amish society. I'm gonna say, hey, for a week, can I sit like way over there on that fence post and just watch? I'm just gonna take some notes, see how you folks commune, see, what the day looks like. And by some stroke of luck, they say, yeah, sure. So I'm watching, mostly they're just going to different houses, going to work, going to eat. But this one day, I see them all come outside, and they bring these chairs and they sit them in a circle, and they dance around these chairs, and then they all stop. It's almost like a musical chairs, but they're standing on the outside. And then when they stop, they throw them in the middle, and somebody lights them on fire.
They're a community, not a cult.
And then they keep dancing around the fire of chairs. The chair ceremony I heard so much about. What's the problem? So I'm sitting back here and I'm like, chairs in circle, dance around chairs, chairs to fire, more dancing. That's it. It's my problem.
You don't know the reasoning behind their actions.
I have no clue what the hell they're doing, right? If I see something that is mysterious or that I need more information about, there's not really a way I can get that, is there? I mean, if I'm just doing the observation and I'm not allowed to follow up, I'm not allowed to ask questions, and I just see this thing happen, well, I can either just report it, this is what happened, or I can try to guess. This is a celebration of the Pentecost because of the fire. And they just do it differently. It's a Catholic thing. But I don't know, I'm just making it up. So here's a drawback of the observation, right? Is I can't dig in. I can't get my questions answered. I might see something that's fascinating and have no clue what it is. I'm only just observing it. I can only really report that it happened. And I'm still not exactly sure, am I, that it applies to every community, right? I go to Pennsylvania and I talk to some Amish folks there. They're like, what do you mean a chair ceremony? That's weird. We use tables. The other drawback of the observation is, let's say I'm a lion researcher. I'm really interested in how lions hunt. I go out, I watch lions for 3 weeks, and they never hunt. The other drawback of the observation is if I have a specific thing I'm interested in, right? If I'm not just broad interest in Amish culture, if I'm interested in lions, hunting, elk in particular, then I might not get what I want to see. I might stay out there for months and they only ever hunt boar, right? So the other problem with the observation is you don't have a lot of control, right? If you're interested in a specific research topic and you're just observing, you're not setting up how that observation is gonna go, you're just hoping for luck that they do the thing that you wanted to see. Questions about observation? Notebooks, always weird. Okay, next is the correlation. Now this isn't exactly a method of study. This isn't necessarily something you would do to the subject. This is really more something you might do with the data. So you might get this data from a case study, you might get it from an observation, or maybe even one of the next two that we'll talk about. But who knows what a correlation is? This is something you've probably heard of. Yes, sir?
Correlation is like when you have two different sets of data, but the way they,
So the way they,
look very similar when
okay,
when you compare.
You're fine. So they can look similar when you can compare. So let me help them out. Correlation.
They relate to each other.
They relate to each other, right? We're really just trying to see how two sets of data are associated, how they relate. Maybe how they affect each other, but we can't talk about that in correlation. So easy correlation, of course, is maybe I just look at somebody's height and I compare it to weight. I won't do this to you, but if I went around and said height, weight, height, weight, height, weight, height, weight, right? I'd get all these data points. Say I started at 4'10" and I went up to 6'5", right? And I started at, I don't know how much people weigh, 100 pounds, and I go up to 350, right? And we would probably expect, like, so for instance, let's say here's a 5-foot woman and she weighs 110 pounds, that'd be her dot. Here's a 6-foot guy and he weighs, I don't know, 220, here's his dot. And we start filling in people, right? We just start making dots for different heights and weights. And we're basically just looking for a trend, right? And here is our trend, right? We can basically see that it has a shape where it's going in this direction, which from geometry, you should understand is just a slope formula. Positive x, positive y, positive slope, right? This positive slope just indicates that they go together. When one goes up, the other goes up. There's a positive correlation. They move in the same direction, right? What's something that you might expect to be negatively correlated? That is to say, what's something that you might expect when it goes up, something else goes down? What do you think? Negative correlation. This goes up, this other thing goes down.
Like the population of a predator would make the prey population go down.
Okay, good. So let's go back to our lion elk study. That's great. So we've got our lion population, we've got our elk population, right? Start both at 0, and here's, I don't know, how many elk there could be, 500, 500, right? And this idea is, right, if there's a lot of lions, let's say 400 lions, and there's probably going to be relatively fewer elk because they're eating them. Here's our dot, right? But if the lions go down, if there's 10 lions, there's probably gonna be a lot of elk, say 450, so here's our other dot. Right, and we start filling these in, get them along the way. We develop a negative slope, right, because line's going up, positive x, negative y, or if you like, negative x, positive y, then you're gonna have this negative slope. Again, that just indicates a negative correlation, which means as one thing goes up, the other thing goes down. This makes sense? Practical math. Let's look at another correlation. See if you can make some understanding of it. If you know this, don't shout it out, but the other class do want it for a second. I feel like you might know everyone. So, this is a real correlation, okay? And this is a positive correlation, so as one thing goes up, the other thing also goes up. It turns out that there is a positive correlation between ice cream sales, it's ice, and murder. Sell the more ice cream is sold in a particular place or at a particular time, the more murders there are. This is a real correlation. So do you think that people are going to buy ice cream and it's pissing them off so much that now they gotta go murder somebody? Ah, chocolate ice cream makes me mad. Watch out. Is this what's happening? Okay, let's try it the other way. Do you think when somebody goes to murder, like, boy, you know what I could use after a good stabbing? Some ice cream. Is that the way of it? It might be. So there's some correlation here, but neither of them, right? Neither of them really seem like that doesn't make any sense. I'll give you the answer in a second, but what I'm trying to point out is that one very important aspect of the correlation that we understand is that correlation does not equal, that's what the symbol means, does not equal causation. If you take more psychology classes, you will hear this over and over again. Correlation does not equal causation. Causation just means from the correlation, from the fact that these two things seem to be associated, that they move in the same direction, we can't infer causality. That is to say, scientifically, I cannot say that ice cream sales cause murder. I also cannot say that murder causes ice cream sales. All I can say is that they are associated. Ice cream sales and murder are associated. This is important because sometimes we get it wrong, and even when we get it right, we are still careful in science. So of course we know smoking is associated with lung cancer, but if you pick up a pack of cigarettes, I don't know if it says it now, but it used to not say, smoking causes lung cancer. It used to say, it may still say this, smoking is associated with lung cancer, right? Is that right?
Yeah.
And so, because again, we find this out by causation, this isn't the type of thing where I'm gonna say, hey, you go smoke for a couple of years and then we're gonna see if you get cancer. That's unethical, because we know there's an association. So I'm not gonna just go make somebody do it, but that's how I would find out for sure. That's how I would know. I caused that, I did that one, right? But we don't, we just have people show up to the doctor, they've got lung problems, you say, do you smoke? And they say yes, so we get a data point. And that's it, right? And we just fill this data point out, or this correlation out, until we see there is an association between smoking and lung cancer. But again, a good scientist will not, even with something that seems clear cut, will not say cause, right? It's just good science. You You can't say it's caused unless you have watched it cause it. So what's happening here? Do you know the answer, or are you gonna guess?
Probably more of a guess.
Good, I like guessing.
So is it talking about how in cities they have more sales of ice cream, but also more murders?
Well, yes, that is what it's talking about. Do you know why?
Because population and whatnot?
Oh, you're saying it has to do with city, like population. That's a great guess. It's something like that, but it's not that. Very good. What? Yes, ma'am?
Could it be just like, it's summer, so like people are more active, including like people buy ice cream and murderers?
There it is. It's summer. It's not quite summer, but it's heat, right? This, and one of the reasons we can't infer causation is because this happens all the time. This is actually two correlations with something that ties them both together, right? What are those two correlations? Do you know?
Time?
No, you said it, right? So these are two correlations broken up. The first one is murder and heat. And the second one is ice cream sales and heat. Turns out these both have a positive correlation. And so when I just look at these, when I just look at these, because they share a common thing, right? When school starts, the leaves fall off the tree. Well, the falling of the leaves may be causing school to start, since it's a season, but you get what I mean, right? It's not an exact cause, there's something in the middle of it, right? It's fall. That's really the thing that's linking these together. And so you get these two correlations that can make it look like this strange correlation appears. And this is why we have to be super careful about causation, because we need to do more science to actually figure out, oh, this is actually talking about heat. It's not talking about ice cream or murder really at all, or at least that connection. This is just a coincidence, right? In the summer, both of these things are happening. Questions about this? Correlations. I really want you to understand that, I don't know what time it is. I really want you to understand that a correlation requires two variables, okay? Correlation requires two. If you get complicated, you can add more, but at least two variables. What we're gonna talk about on Thursday, when you see that video, is the bell curve. And a lot of folks will get this confused with the correlation, but the bell curve, and I'll just tell you this now, only uses one variable, only uses one thing. I can only put ice cream sales on here, or murder on here, or smoking on here, right? I'm only gonna put one thing on a bell curve. So next time on Thursday, we'll finish out this list. There's two more things here. Those will be survey and experiment, and then we'll move into talking about normal curves, normal distributions, and then that'll be it for the science section. And then next week, actually the next 2 weeks, we'll be talking about biology. So next time I see you, we'll be talking biology. All right, have a good day.